So good morning. This is Unit 1, Day 2 notes. We're just going to go a little bit more into graphs. So the first one just says x is the directed distance from the y-axis, while f of x, or y, is the directed distance from the x-axis. We learned last time about the vertical line test and how that's a way to determine if the graph is a function or not. Remember that if it is a function, it's only going to pass that vertical line at one point, or no more than 1 point. This one is just kind of like a fancy way of saying increasing. If our second y value is bigger than the first one, then we're increasing. Now, if the second y value is less than the first one, then we are decreasing. And if our y values are equal, then that's called constant. We're going to stay the same or be constant. A function is even if for each x, f of negative x, if we substitute in a negative x, we get the original function. And just remember that the graph of the function will be symmetric about the y-axis when it's even. Kind of like a parabola. A parabola is even. If the function is odd, then every single sign will change when you substitute in negative x. Every single sign of your function will change. And this one will be symmetric about the origin. So we're going to talk about domain and range of a function. Kind of went over it a little bit yesterday or last class. The graph of the function f shown below, find the following. We're asked to find the domain of f. So it looks like it starts right here at -2, doesn't go to the left of -2. So it's going to start at -2, and it goes up until 4. So we're looking at the x values. The domain are our x values. So -2 to 4. Now I want you guys to take a look at these circles. The -2 is an open circle. That means I cannot include -2, but 4 is a closed circle. I can include 4. So I'm going to use a bracket for closed if I can include it, and then a parentheses if I cannot. Now I'm going to find out what my function is defined at 0. So what is my value when I plug in 0? It looks like my value is right here, -3. What happens when I substitute in 2? So I'm going to go to 2 on the x, and I'm going to go down to my function. It looks like my y value is -5. The range of f, the range are my y values. My y values. My range, I'm going to always start at the bottom. It looks like I go all the way down to -5. I can include that because that's actually a point, so I know that -5 is inclusive, so I'm going to use a bracket. And I'm going to go all the way up to the highest y value is 3, but since that one was the open circle, I cannot make a bracket. That's going to be a parentheses. So this one, they're giving us the implicit equation, but they want us to make it into the explicit equation. So we're going to solve for y. In order to do that, I need to first move over this x squared, but it's negative. So in order to move it over, I need to add x squared on both sides. And then I'm going to be left with 2y equals, this becomes 0. And I have x squared plus 4. And then I am going to divide every single thing by 2. And this is a parabola. It's a pretty simple parabola. It is y equals 1/2 x squared plus 2. It does say you can use a graphing calculator or Desmos to graph it, but I know it's going to look something like this, and maybe like to 4. If I plug in 2 into here, it's going to be 4 divided by 2 plus 2, so it's going to be right there, and it's symmetric, so I'm going to do this. And this is what this parabola looks like. It wants us to use a vertical line test, so any vertical line that I create is only going to touch this parabola once. Parabolas are almost always going to be a function, unless they are on their side. So we can say yes, it's a function. This is what they're asking us. Kind of went over this last time. Let's look at this one. This is a little bit different. So I'm still solving for y. I have to subtract x on both sides. And I'm going to get negative y squared equals negative x plus 1. And I still have to divide by negative 1 to get rid of the negative. And every single thing has to be divided by negative 1. So I get y squared equals, and then x minus 1. And then I actually have to take the square root of this. But remember, whenever you take the square root of something, we always have to do plus and minus. So this is y equals plus and minus the square root of x minus 1. So the square root of x minus 1, actually, usually the square root of x kind of looks like this and goes up very slowly. But it's going to be moved to the right one. Remember, whatever's under the parentheses, we kind of do the opposite of. So instead of moving it minus 1, we're going to move it to the right one. And this is going to be your, the top part of it, the plus the square root of x minus 1. Now, the minus the square root of x minus 1 is going to look like this. So this is your parabola. It's kind of also going to be a parabola, but it's on its side. So is this going to pass the vertical line test? No. So it's going to touch it twice. So we're going to say no, does not pass. It is not a function. It is only a relation. Relation only. I want you guys to try part C. I'm going to keep going. So we kind of touched on this a little bit, increasing and decreasing. Consider the function shown moving from left to right. Complete the following statements. This graph falls or decreases. Or goes down. From what value to what value? We're looking at the x's. So when x equals, we're talking about when it goes down. It only goes down, we always look from left to right, from this x value to this x value. So this is when x equals negative 1. All the way until x equals positive 1. Now, constant means we're not going to go up or down. It looks like it's constant right here. And this is when x equals 1. They should not completely overlap, but where one ends, the other one should pick up. So this is x equals 1 until this is 5. X equals 5. And then we're going to rise or increase. We're usually going to use the word increase from this point all the way up. So this is when x equals 5. All the way till we end. So this is x equals 7. So that's not too bad. It says use a graphing utility to determine the open intervals on which the function is decreasing or increasing. I want you guys to try this. Just plug it into the y equals on Desmos or your graphing calculator and find out where it increases and decreases. Relative maximum and minimum. We're going to go over what this means. I want you to pause the video and go ahead and read it to yourself. I'm going to go over what this means. So let's take a look at this graph. the relative minimum. Label the points of the relative maximum minima. So I'm going to do the relative minima are these points right here, kind of where there's a valley. And then the relative maxima are going to be in blue. Okay, so let's keep going. Approximate extrema. So it says use a grapher, sketch this. So they mean a graphing calculator or Desmos. And we're going to graph this and determine the local extrema value, give values around to 2 decimal places. So we're going to use 2 decimal places. The minimum. Your calculator will do this for you. The local minimum is going to be right here. What we're going to do is actually use the calculator and it will help you find the minimum. So when I used my calculator, it told me that this point right here is negative 1.15, comma, 4.08. And it told me that this point right here was 1.15, comma, negative 2.08. So try it. Let me know. Please ask me now if you have any questions. Just pause the video and ask me. So the local maximum value is going to be, this is our point, but the maximum value is our y value. So it's going to be 4.08. And this is where it happens. This is our x value. So it occurs when x is approximately equal to negative 1.15. Now, my local minimum value, remember this is your y value, and this is the minimum one. So my y value is going to be negative 2.08, and this occurs when x is 1.15. So remember, if it's even, odd, or neither. So all I'm going to remind you is that if your graph is even, then it's symmetric about the y-axis. And if it is odd, it's symmetric about the origin. If it's not symmetric about either of those, then you can put neither. All right, I want you guys to try these and let me know if you have any questions. Have a wonderful day.